Hello friends, today we will discuss about the assignment problem and we will discuss in this class about the special cases of assignment problem. So we have three different special cases in the assignment problem, and those special cases are: first one is the unbalanced model, next one we have profit maximization, and third one is the restricted assignment. So we will discuss one by one about the special cases of assignment problem, and that is the unbalanced model. Then we'll discuss about the profit maximization, and then finally we'll discuss about the restricted assignment problem. So we'll start with an unbalanced transportation problem. So in the earlier classes, we have seen about the Hungarian method, in detail about the Hungarian method. So in this class, we'll discuss about the special cases of assignment problem. So first, we will start with the unbalanced model. So we will start with the in the unbalanced model. We will start with one problem, and we have a problem. So we have this problem. We have means we have three different jobs. We have three different jobs A, B, C, and we have three different contractors 1, 2, 3, and 4. We have to assign our job to these contractors. So we have three different jobs and we have four different contractors. We have to assign our job to any of the contractors. So in this case, we have three jobs, and other hand we have four contractors. So this is a unbalanced model. So to balance this model, to solve this model, we have to balance it. So for balancing the model, what we will do, for before using the Hungarian method, first we have to balance the model, balance the matrix. So what we will do, we will add one dummy column. If there is a scarcity of one column, then we will add one column. If it is a lack of one row, then we will add one row. So in this case, we have added one dummy column. So this is the way by which we are balancing the given unbalanced assignment problem, and we are balancing it. So we have balanced the given unbalanced problem. So we have balanced. So for that, what we have did is we have added one dummy column. Since in this particular row the minimum value is 0, for this particular row the minimum value is 0. So since each row the minimum value is 0, so we will not go for doing the row transaction. Means we are not going to subtract the row minimum from the each cell. We are directly going to find the, we are going for finding the step 2, means we are going to find the column transaction. So we are not going to, this is already row transaction is completed, so we are going for column transaction. In that case, what we are doing is we are finding the column minima. We are going to find the column minima and subtracting the column minimum. So we have subtracted the column minima from each cell. Since in this particular cell the minimum value is 0, so this cell will remain as it is. So we have obtained the column minima. Now we'll go for finding the, so this particular matrix we have obtained after the column transaction. Now we go for finding the solution. So in this particular column only one 0 is there, so we have picked this particular 0. Since this in this row this 0 is picked, so we can cross this particular 0. Now in this column, or you can say, so only one is 0, so we have picked this 0. Since we have picked this 0, so we can cross this particular 0. So we have crossed this 0. Now in this particular column, we have, in this particular rows we have only one 0, so we have picked this 0. Since we have picked this 0, so we can cross this particular 0. Next we will pick this 0. So likewise we have assigned the three different jobs, including if we'll add the dummy as well, so we have four different jobs including the dummy to four different contractors. So this is the assignment we have assigned. We have assigned the job A to 1, job C to B to 2, and job B to 3. We have assigned dummy. We have not assigned any job to contractor 4. So this is the assignment we have did by making use of Hungarian method. So now we'll find the minimum assignment cost, and how we are finding the minimum assignment cost. This is the assignment we have obtained by the Hungarian method. So now we'll find the cost. So for contractor 1, the job A is assigned. So for this is cost is 9. For 2 it is C. So the cost is 6 unit. And for 3 it is B. So cost is 20 unit. And for D and for 4, oh, it is D. So there is no cost for D. So that is 0. So we will say that this is the cost, and the minimum assignment cost we have is the 35 units. So this is the one of the special case, that is the we have solved the unbalanced assignment model by balancing it and by making use of the Hungarian method. So in Hungarian method, what we have did is we have did the row transaction and column transaction. Next we'll find the solution for the second case, and that case is the cost. The second case is the profit maximization case. So let us say this is the problem for finding the minimum assignment or for finding the maximum profit. So this is a maximization type of problem, but till now we have only discussed the minimization type of problem in the assignment model. So what we will do, we will to solve this maximization type of problem by making the minimization. What we will do, we'll pick the highest value. So in this particular matrix, we have the highest value is 60. So what we'll do, we'll subtract each cell value from this 60. So this is the very first step for solving the profit maximization or any type of maximization problem in the assignment model by making use of Hungarian method. So what we'll do, we'll find the highest value in the given matrix. So in this particular matrix, the highest value is 60. So we will subtract each values from the 60. So we have subtracted each value from the 60. So this is the matrix we have obtained after subtracting the each value from 60. Now, if you will find the assignment, then after that we will find the maximum profit. So how we will find the assignment? So we will find the assignment. We will do the assignment. So in this case, we have 3 different jobs and we have 3 different contractors. So we have to assign these jobs to these contractors. So in this case, we will also again use the Hungarian method. Now we will solve this particular like same as it is finding the minimum assignment cost. So we'll solve in the same way and we'll finally do the assignment, and after that we'll find the maximum profit. So for this particular row, what first step we will do, we'll find the row, we will go for row transaction. Means we'll find the minimum value in the row and we'll subtract that minimum value from the each cell. So in this particular cell, the minimum value is 25. In this particular cell, in this particular row, the minimum value is 0, and in this particular row, the minimum value is 15. So we will subtract these values from the remaining cell, from the all cell in the row, respective row, and we'll find the, this is the matrix obtained after the row transaction, means after finding the row minima and subtracting the row minima from the cells in the row. Then we'll go for finding the column transaction. We'll go for doing the column transaction. How we'll go do the column transaction means we'll find the column minima. So in this column we have 0 minima. In this column we have 10 as a column minima, and in this particular column we have 0 as a minima. So these 2 columns will remain as it is after column transaction, after finding the column minimum and subtracting that value from the remaining cell. But this cell will change. So the matrix obtained after the column transaction is this. So we have obtained the matrix after column transaction. So 0, 0, 5, and we have subtracted 10 from the each value. So we have subtracted 10 from each value. So after subtracting 10 from each value, we have obtained. So this is the matrix we have obtained after the column transaction. So after column transaction, we have obtained this particular matrix. So this matrix we have obtained after column transaction. Next, we'll go for the solving for the solution matrix. How we are finding the solution matrix? So this is the matrix we have obtained after the column transaction. Now we'll go for finding the going for the assignment. So how we'll assign? We'll assign. So in this particular row we have only 0. In this particular column we have only 1 0. In this particular column only 1 0. So we'll select these 3. So we'll select these 3 values. So we have selected these 3 values. So we have selected these 3 values. So this is the assignment we have obtained. So we have assigned job A to 1, job B to 2, and job C to 3. So this is the assignment we have obtained on the basis of by using Hungarian method. In the same way, we are solving the minimization type of problem. So we have did the assignment. After that, this is the assignment 1A, 2B, and 3C. This is the assignment. So we will find the matrix. We will find the maximum profit. So this is the profit matrix we have given in the question. So we have given in the question this particular cost matrix. So from this we have for 1A it is 35, for it is 50, and for 2B and for 3C it is 45. So this is the maximum profit we have obtained. So, and that maximum profit is the 100 and 130 unit. So from this study we can say that we are using Hungarian method for finding the maximum profit or for profit maximization type of problem. And in that particular problem, what we have did is we have subtracted the each values from the maximum value or from the highest value, and we have solved the problem in the same way like in the minimization type of problem. So this is the final solution of the final optimal solution of this particular problem, this particular maximization type of problem. So maximum profit we have obtained from this particular solution is 130 units. Next, we will talk about the third case, and that case is the restricted assignment type of problem. So in the restricted assignment problem, this is the fact. So this is the question we have. We'll solve one question based on the restricted assignment. We have mentioned here 2 lines about the restricted assignment. What is restricted assignment? In practical cases, we are also finding some technical issue due to some technical problem. Some combination is blocked or some combination is restricted, and that type of problem is we'll say the restricted assignment problem. In such cases, what we are doing is we are placing infinity value. We are assigning infinity unit cost to that particular restricted cell, and we are solving the combination in the same way like we have solved the question earlier. So we'll take one problem and we will solve this concept. We'll discuss this concept with the help of that particular problem. So this is the question based on the restricted assignment problem. So in this question we have to restrict this A3, means we have to assign some infinity value to this A3. So we are restricting as A3, means we are assigning this as a infinity. So we are going to assign this value as a infinity. So we have to assign it as infinity. So we have assigned this infinity value. So we have assigned this as infinity value. So we have assigned the infinity to the restricted cell. Now we will solve the given problem by making use of Hungarian method in the same way we have solved the earlier problem. So what we will do, we will go for finding the row minimum, and we are subtracting the row minimum from the each cell. So in this particular row we have 5 as a row minima. In this particular row 3 is a row minimum, and this row 3 is the row minimum. So if we are going to subtract this particular value from each row, so if we will subtract 5 from infinity, it will remain the infinity. So we are going to subtract this value from each row. So we have obtained this particular matrix after row transaction, or you can say after subtracting the row minimum from each cell. Now we will go for column transaction. So in column transaction, what we are doing, we will find the minimum value in the column and we will subtract the column minimum. So in this column, the minimum value is 0. Here it is 0. Here it is 3. Again, if we will subtract 3 from infinity, it will remain the infinity. So we are going to obtain the we are obtain the column matrix having we will obtain the after column transaction. So this is the matrix we are obtained after the column transaction. Now we will go for finding the optimal solution. How we are finding the optimal solution? Means we'll pick the zeros. So in this particular row, only 1 0 is 0 there. So we will pick the 0. In this particular, since we have picked this 0, so we can cross this 0. Because 2 0 is not possible in a column. In this particular row, only 1 0 is remaining, so we will pick the 0. And in this particular row, this 0 is there, only 1 0, so we will pick the 0. So we have assignment, and the assignment we have is A2, B3, and C1. This is the assignment. So now we'll find the assignment cost, minimum assignment cost, and this is the matrix we have given in the question. This matrix. So A2 is the 5, B3 is the 6, and C1 is the 3. So this is the cost, and the total minimum cost is the 14 unit. So this is the total minimum cost we have obtained in the 14 unit. So right now we have discussed three different special cases of assignment problem, and these special cases are the unbalanced model. Next is the profit maximization, means maximization type of problem we are, and in that case what we are doing is we are subtracting the highest value from the remaining value, we are subtracting the each values from the highest value. And in third case we have discussed about the restricted assignment, in which we are assigning the infinity value in the restricted cell, and we are solving the given question in the same way we have solved earlier one. So with this we have discussed three different special cases of assignment problem. So thank you so much. We will stop the class over here only. So we will discuss, we will see next in the next class. So thank you so much.